Before starting this video, I want to let you guys know that Coding Cleverly also has a Patreon page. So go to patreon.com/codingcleverly and you'll see that there is a Patreon page that is available, and you guys could support the channel by just joining any one of these tiers. That would also motivate me to provide better and better content. So all you got to do is go to this page and show some love to Coding Cleverly. Alright, enough with the shameless plug. It's coding time with Coding Cleverly. Today we're going to be talking about asymptotic notation. We're also going to be looking at time and space complexity in this video. Asymptotic notation is often used to describe the runtime of a program or algorithm, but it can also be used to describe the space or memory that a program or algorithm will need. Now for the example, think about a simple function that takes in two numbers and returns their sum. So we have this function here that takes in two numbers and returns their sum. This function has a space complexity of O of 1 because the amount of space it needs will not change based on the input. While this function also has a constant runtime of O of 1, not all functions have matching space and time complexities. Now this is the topic that we're going to be addressing here. If I had a constant runtime of O of 1 for this function, that doesn't necessarily mean that I will also get a O of 1 space-time complexity for this same exact algorithm. Now, if we look at this method over here, which is the simpleLoop method, we're having an input parameter, which is an array of ints, and we're going through a for loop. We gotta notice something very important over here. As we know, a simple for loop that goes through every element in an array of size n has a linear runtime of O of n. However, this function takes O of 1 space since no new variables are being created, and therefore no more space must be allocated. So you're not creating any kind of space here. So the runtime is O of n. So the runtime is O of n, but the space time is actually O of 1. Since there's no more space being allocated. Like with time complexity, space complexity denotes space growth in relation to the input size. It's also important to note that space complexity usually refers to any additional space that will be needed and doesn't count the space of the input. So these input parameters don't matter at all. You only look into the body of the functions for observing the space complexity. So even if you have 10 input arrays passed into this input parameter, you will still have O of 1 space if only you are just printing hello world inside of the function. Alright, so now look at these two different methods here. Now both of these functions have a big O runtime of O of n, but what are their space complexities? Now let's look at the function above here. So we have a static method here which says it returns an array. It says doubleArray and it passes in an input array. Now it says doubleArray here, so it's creating a new variable. Okay, so new int, and it's getting the length from the input parameter. I is equal to 0, I is less than input array dot length, and then we have I plus plus doubleArray sub I, which is this array. So every index you're gonna multiply 2 with the current input array sub I. Alright, so you're doubling each element here and then return the doubled array into this thing. So this is actually creating some kind of additional variable here, and it depends on the input size. If we look at the other method here, public static int findMin passes in an input array. What we could see over here is a variable is being created which is min, and the input array sub 0, the first element is in the min. Then after that we're having I is equal to 0, I is less than the input array dot length, and then we have I plus plus. Now we look at if the input array sub I, which is each element in the input array, is less than the min. If it is, then we're gonna assign the min to the new input array sub I. So we're just trying to find the minimum value within this array, and then we return that minimum. Okay, doubleArray creates a new array that matches the size of the input array. So the space needed for this function will change as the size of the input array changes. It depends on the input. findMin, on the other hand, only creates one int variable regardless of the input, so its size is constant. Space complexity is important to consider alongside time complexity when comparing data structures and algorithms. While two functions may have very similar runtimes, one could use less space. So the solution here was that both of them have a runtime of O of n, but the space complexities are different. The first one has a space complexity of O of n because it depends on the input size, and the second one has a space complexity of over 1 because it's just creating one variable regardless of the input array. Consider the double array function from above. It has a runtime of O of n and takes O of n space. Could we optimize it to have a better space complexity? The answer is yes, and you could see this by this improved version of the function, which is defined here on the bottom. So doubleInPlace does the same thing as doubleArray and in the same amount of time, but only takes O of n space. But how is that possible? It's simply because it doesn't create a new array. So you can see over here, we're iterating through the entire input array till the length and I++. And instead of creating a new brand new array, just we did like over here, doubled array, we're actually modifying that same array. So we're saying each element multiply equal to 2. So this is the inPlace method. So doubleInPlace, and then after that we return the modified input array. Thank you so much for watching this video. I hope you had a blast. I hope you learned a lot, and keep subscribing and supporting the channel. I'll see you guys in the next one. Peace out.